Hello everyone, and welcome to this Blender tutorial where I'm going to show you how you can make this procedural cartoon flame effect and then create some variations to suit different styles. Also, in terms of tooling, in this tutorial I'll be using Blender 3.5 and I'll be working in the EEVEE render engine, but the cool thing is that the shader that we'll make also works in Cycles. Okay, so let's hop into Blender, and to begin with, let's press X to remove our startup cube, because instead we want to make our base flame mesh, and it's going to be an icosphere. This is interesting because if we tap into edit mode, select this vertex at the top and then enable proportional editing over here in the toolbar, then you see that by dragging it upwards, we're also moving the other nearby vertices, and so we instantly get this teardrop-like shape that looks a lot like a low-poly flame. Of course, we can also shade it smooth to get something more adapted to our soon-to-be effect, but other than that, that's actually all we need in terms of modeling. So now if we go to the shading tab of our editor and we change our top view to render mode, we see that we have the basic visual of our new mesh with its default grey principled BSDF material. This built-in material node is great for physically based rendering, but in our case, since we want to do a cartoon-like effect, it's not really what we want. So let's press X and delete it. Today, the main idea for a flame effect will be to use Blender's texture nodes, that are various mathematical noises and functions that can produce procedural visuals easily. More precisely, we're gonna want to mix some of those noises in various ways and transform them both into colors and transparency to create those gradients and moving holes in our shape. So for now, let's start simple and create just one node. For example, we can pick the Musgrave texture, which gives us a purling noise and is thus a nice, continuous, fairly large and smooth texture to start with. As usual, don't forget that if you've enabled the built-in Not Wrangler plugin in your Blender user preferences, then you'll be able to press Shift plus Ctrl and click on any node in your shader graph to preview its result on its own. And here you see that this Musgrave texture is indeed a cool first step, because it already creates sort of basic, smooth, flame-like patterns. We can of course tweak its parameters a bit to change the visuals to our liking. But then, the real trick is to play around with the position of this noise. To control this, we're going to need two new nodes, a texture coordinate and a mapping node, plugged into this noise texture. And if we have the Not Wrangler add-on enabled, we can get them very simply, just by pressing Ctrl plus T. Now you see that if I decrease the Z coordinate of this mapping position vector, then our texture pattern starts to scroll upwards, just like a real flame. Okay, so that's great, but now the question is, how can we animate this value over time? Should we keyframe it in the timeline? Well, we could do that, but another super cool technique that is particularly useful for shaders is Blender's drivers system. In a nutshell, a driver is a tool that lets us control the value of a property in our scene based on a mathematical formula. And the great thing is that it can access a lot of global notions, such as, in our case, the current frame of the scene. So if we write an expression based on this frame value, then we'll effectively have a computing function that updates the value of our Z position every frame, and thus we'll have animated our texture noise. To create a driver, the quickest way is to edit our property by clicking on it and type in a hash symbol. Then we'll write our math expression. For example, here I'm going to multiply the current animation frame, which is given by the frame built-in, by a small negative factor, and then if I press enter, you notice that the property turns purple, which indicates that it's being controlled by a driver. You can always right-click on it and use the Edit Driver option to see what formula this data slot uses and modify it if need be. But in any case, now if we open up the timeline in our editor and we start to scrub our playhead around, you see that our purling noise indeed scrolls up and down as expected. And so we've just animated our texture directly inside our shader without having to do any extra keyframing. Alright, we're starting to have something interesting here. But of course, using just this single Musgrave texture isn't enough. For now, it doesn't really look like a flame, because this texture on its own is too large and smooth. The next step is to add some granular noise to all this, to get different levels of details. So let's add another texture node in our graph, and more specifically, a simple noise texture. If you preview it, you'll notice that it's indeed way smaller, and that we can turn it into a nice details layer by changing its parameters, and most notably, increasing the detail and distortion values a little. Then let's redo the same as before and connect it to our texture coordinate and a new mapping node. We'll create another driver on the Z position, this time with a bigger factor to have these smaller particles move slightly faster. Finally, all that's left to do is to mix those two nodes together. For that, we can create a mix node in color mode and plug our two texture outputs in its A and B slots. Then let's also change the operation to soft light and set the factor to 1 to better mix our two noises. Okay, this is looking really neat. We now have a nice blend of large and small patterns with different levels of details. We can now enhance it even further by adding a third noise, of course, and for this one, let's go for Voronoi noise. Now, we talked about this noise in this previous episode on the channel, about making a procedural crystal material, and in particular we said that depending on the mode that you pick for this noise, you can get very different results that can adapt to many use cases. Here, however, the default F1 Euclidean combo is quite cool, because it creates sort of bubble shapes that will complement the rest of our layers nicely. So just like before, we'll tweak its parameters to fit our style, connect it to the texture coordinate via a new mapping node, with a driver on the Z position, and mix it with our previous result using another soft light mix color node. At this point, we have a simple blend of patterns that already looks quite a lot like flames, but we're missing several important features, among which the cartoon effect. Now, of course, there is no absolute toon style, so you can absolutely transform and interpret this idea as you want to create your very own cartoon effects. Still, what I'm calling toon here, besides not doing any smoke effect or realistic particles, is mainly the style where instead of having fuzzy borders to our shapes and smooth textures, we create straight cuts to define the opaque and the transparent parts of our mesh. To do this, we're going to add a color ramp node to our graph, and we'll plug it after our mix nodes. Then the crucial thing is to change its mode to constant, so that we don't get a gradient of interpolated colors, but discrete color ranges. And now if we bring the writer mark to the left, we can control how much black and white we want on the surface, but we also get a clean limit between the two colors. To transform this black and white into opaque and semi-transparent areas, let's add 3 nodes to our graph, a translucent BSDF, an emission BSDF, and a mix shader. Those 2 BSDF will be the 2 shaders that we'll mix together using our third node, and we're going to use our brand new discrete color ramp as the factor value. So basically what we're doing here is that we're taking all the black parts from our color ramp and we're making them translucent with this BSDF, and we're taking all the white parts from our discrete color ramp and we're making them emissive with this BSDF. By the way, note that if we use a darker color for the translucent BSDF, then this semi-transparency disappears and we're back with an opaque black and white visual, so we should probably leave it to a light tint. For the emission shader, we can tune up its strength, and since we're in an EEVEE scene, enable the bloom effect in our scene settings. This way, these emissive parts will create a little glow that really helps to sell the whole flaming thing. Okay, this is a nice way to boost our flame effect, but it still looks quite empty. If we compare this to our end result, you see that we don't have this higher density in the bottom part, and yet that's what really creates the illusion that there's some fuel burning, so we need to get a way to better control this density. To increase our density at the bottom like this, we're going to do 2 things. One, we'll set up a simple vertical gradient to change the opacity of our material depending on the vertical position of our current shading point. And 2, we'll mix it with our previous noises to have this gradient also impact or discretize cartoony translucence mask. So first, let's reuse the trick that we discussed in the tutorial on procedural crystals and compute the vertical ratio of our current vertex to basically get a vertical gradient that spans over our entire shape height. If you're not familiar with this technique, don't hesitate to check out the other video, cause I go into way more details on how to do it. In short, the idea is to extract the vertical Z component from our vertex's position, and here I'm taking its local position thanks to this subtraction, and then we'll divide this Z coordinate by the height of our object to normalize it to the 0, 1 range. Here we can see that our flame height is 3.65. Now, if we plug this into a color ramp and we preview the output, we see that it's not exactly what we expected, because instead of having something that goes from black at the bottom to white at the top, our black color starts in the middle of the shape. That's because, for now, the pivot point of our object is in the middle, and not at the bottom. So we can solve this issue just by going into edit mode, selecting everything, and moving our shape up in the object until its bottom rests on the pivot point. And now you see that we do have a gradient that spans from the bottom to the top of the mesh, and that we can control thanks to our color ramp. Typically, since we want our flame to be denser at the bottom and more transparent at the top, it would be better to flip our color ramp around. This way we'll get higher values at the bottom, and we'll be able to use the output from this color ramp as an opacity factor. Also, we can once again play around with the mode of this color ramp node to adjust the way our colors are interpolated in the gradient. Here, the B-spline option is interesting, because it creates a very smooth gradient. Alright, now with this color ramp ready, let's see how to use it to change our flame opacity depending on the height of our vertex. Our goal will be to have the bottom of the mesh stay opaque, but to make the top transparent. We can do that easily simply by adding a transparent BSDF in our graph and connecting it to a new mix shader node along with our previous shader blend. Then we'll use our new color ramp as the factor and we'll plug the result in our material output node. To understand what we're doing a little better, let's also temporarily make our translucent BSDF black, just so that we're sure our transparency comes from this new logic. And actually, for now, you see that our object is still fully opaque. That's because, in EEVEE, don't forget that you need to explicitly tell Blender that your material needs to support alpha. And you do this in the Material Properties panel by setting the material's blend mode option. So technically you could pick the alpha hashed setting, but it would create this rough pixelated look that doesn't really fit our toon aesthetic. Instead, a better solution here is to use the alpha blend mode, but then, to avoid those annoying visual artifacts, to turn on the backface culling option. This way we only see the faces that are directed towards our camera, so we've made our mesh one-sided, and the faces in the back of a flame don't show and don't confuse us anymore. Okay, we now have a vertical gradient on our opacity, and if we play our driver-controlled animation, we see that this is looking more and more like a cartoon fire. Though, of course, to make these flames even more convincing, we should definitely give them some fire-ish colors. So let's go to the bottom of our graph and create new color ramp nodes for the color slots of our translucent and emission nodes. This instantly improves our material quite a lot. But we're still missing a fundamental ingredient, and that's properly defining the density of the bottom of our flame by tweaking our toon mask. We want to go beyond just having the opacity change vertically. We want to actually feel like there's something at the bottom that is emitting those flames. Now, doing this will mostly be a rerun of things that we've already done previously in the tutorial, so we'll set up a color ramp to invert our gradient colors and control the contrast, and then we'll mix it with our other computations thanks to a mix node in color mode. And in truth, this is where the real magic happens. Cause you see that the minute we do this extra mix, Our noises and our gradient blend together to create a super cool flame effect. Of course, we can then use it as the factor for emission color ramp, and if you want, you can also use it for the color ramp of the translucent. And then we just need to retweak our ramp's marks a bit to fit this new mask. But anyway, we now have a pretty nice fire shader. Note that for this third mix node, the soft color operation isn't necessarily the best one, and something like the add operation can give a better result if you want some basic cartoon flames. But we'll come back to that in just a minute. Just before we do that, however, I want to take just a moment to talk about our mesh. Indeed, at the moment, we've just slightly modified an icosphere, but the geometry in itself is static. And that's a shame, cause no matter how good our shader is, it won't be able to simulate the distortion of the shape that is so typical of a dancing flame. To create this kind of movement, we can use some Blender modifiers. So first, let's add a subdivision surface just to make our mesh a bit smoother. And then, to truly create our distortions, let's add a displace modifier. This modifier is based on a texture, and basically it uses the black and white data in this reference image to move the points of your mesh closer or further away from the center of your shape. For the texture, we can create a simple clouds noise with a fairly small scale, and most importantly, back in our modifier settings, we should change the strength of our displace, and we can even use a negative number to have it slightly expand our flame rather than contracting it too much. Then we can also play around with the mid-level property to change this global expansion. Finally, for the cherry on top, we're going to use an anchor to control the position of this displace modifier. This way, if we move our anchor, our displace texture will move, and our distortions will get translated, which will basically make our flame wobble just like we want. So let's create a new empty anchor in our scene, and rename it to Fire Wobble. Then, in our displace modifier, we'll change the coordinates mode to Object, and pick our new empty from the list. And now you see that if I move the empty anchor, the flame indeed deforms and sort of dances in place. We can of course automate our anchor's movement by using yet another driver based on the current animation frame in our scene. And there we are! We now have a wobbly flame that deforms over time. Now, as a quick side note, as I mentioned earlier, something extremely cool with this shader is that you can create quite different visuals simply by changing the colors and one parameter, the mix operation, in our third mix node. Not all of the operations work as well, but all in all, I find that most of them give cool results that could work for some use cases. Alright, so there we go. Our procedural cartoon flame shader is now finished. So to wrap up the tutorial and reflect back on what we just did, let's quickly go through our graph and group those nodes into organized frames. First, we started with the core idea behind this whole fire effect, which is to use Blender's texture nodes to create black and white procedural noises and move them along the vertical axis to simulate movement using drivers. Then we blended those textures together using mix nodes with soft light operations to get a single final grayscale animated noise output. To better control the density of our flame from bottom to top, we then computed the vertical ratio of our current vertex in local coordinates, just like we'd done in this previous episode on how to make a procedural crystal. This gave us a vertical gradient that we could invert to have white at the bottom and black at the top, and then remix with the previous results to define the density and the style of our flame. In particular, we saw how simply changing this operation in the third mix node can create vastly different flame effects very easily. Our vertical gradient also impacts the overall opacity of our flame, since we used it as the factor for the mix shader that blends a completely transparent BSDF with our base color. And last but not least, our stylized black and white result from before is used for two things. First, as the input of a discretized color ramp to get our cartoon clipped alpha on the flames themselves. And second, on our color input, to change those values depending on the height of the current shading point. These final color ramps are used in a translucent and an emission shader nodes to create some semi-transparency between our flame chunks and give those fire parts some energy and some cool glow effect. And on that note, that's it for today. And you now have a cool procedural cartoon fire material that can be easily adapted to various use cases. I really hope you enjoyed this Blender tutorial and that you learned a few things. If you did, feel free to like the video and subscribe to the channel to not miss the next ones. And of course, if you have other ideas of cool Blender tricks that you'd like to learn, tell me in the comments. As usual, thanks a lot for watching and take care.